Welcome back to Discovering Geometry with Mrs. Berry. This is lesson 51. Today we're talking more about area, and we will be specifically doing problems involving area calculations. So we have many examples today. Remember that area in the geometric sense is the 2D space that a shape occupies, or the measure of the region enclosed by a figure. It is measured in units squared, such as inches squared, or feet squared, centimeters squared. We have now learned the area formulas for many types of shapes. In this lesson, we will combine different formulas to measure the area of an irregular shape. Here's our first example. You can cut out the shape and take measurements, or you can just take measurements on your paper to find the area. What units would be best for measuring this shape? I chose to use inches. So I took measurements around this trapezoid and I found the top to be 1.75 inches, the height to be 2 inches, and the bottom base to be 5.125. That'd be 5 1/8 inches. So what is the formula for the area of a trapezoid? It's the height times the average of the bases. That's how I like to think about it. It's the bases added together, 1/2, and then the height. So here we have all those measurements. We have the bottom base at 5.125, and we have the top as 1.75. So we average those, or take them, add them together, and divide by 2. And then we can multiply by our height of 2 inches. We can actually see right here that 2 times 1/2 will cancel out. So at the top, we'll just have that the area is 5.125 plus 1.75, and that is 6.875. And that is going to be in inches squared. In this example, how would we take measurements from this figure? When I used my ruler on the paper, I found out that the inch mark seemed to be a very good marker for this one because those sides of the square were exactly 1 inch. So I chose to use inches instead of centimeters. When I looked at this, I didn't quite know how to take this section and this section, and then I looked and thought, this section I think can be pulled out and turned around to put right here, and then it would make a solid square. So I have a solid square here, here, and here. That would make 3 solid squares. And the square is 1 inch by 1 inch. So the area of just one of those squares is going to be 1 inch squared because it's 1 times 1. And I have 3 squares. So I said that the area of this figure was 3 inches squared. 3 squares times 1 inch squared each. Example 3, use this shape to take measurements to find the area. What units would be best for measuring? You could continue to use inches. I chose to use centimeters on this shape. I'm also going to break the shape into different rectangles. So my first rectangle up at the top is 6.5 times 4.5. I then have this medium rectangle, 3.5 times 4.5, and then I have a small one, 1.5 times 2. So 6.5 times 4.5, the area of a rectangle is just base times height. Then I'm going to add the medium rectangle, 3.4 times 4.4. I'm sorry, 3.5 times 4.5. And then I'm going to add the small one, which was 2 times 1.5. So that is all for my area of this figure. I'm going to get 29.25 plus 14 plus 3. And then I add all of those together and I get 46.25. I measured in centimeters, so that's centimeters squared. So why is this useful? When we think about building, renovating, or decorating houses or other buildings, we're going to use many of these skills. Because not all rooms and sides of a building are perfect rectangles. We're going to have to piece together some things. We might have to subtract a window out of the wall. So think about how the construction and decorating business would use the calculations of area in their work. Could we order 11 1/4 of a gallon of paint? What about using 5 3/4 rolls of wallpaper? So when we're working in real life, we always need to round up. We don't ever want to underestimate what we need to finish a room of paint or a room of wallpaper. Think about that as you're doing your homework and looking at the problem that you have, and make sure that you are not underestimating and that you're rounding up whenever you need something like a gallon of paint, a roll of wallpaper, maybe square foot of carpeting. Our last example today, this is the information center at a state park. And Harold works here and he needs to seal the deck at the information center. He measures the deck and finds that it looks like a kite with diagonals of 40 feet and 70 feet. Each gallon of sealant covers 400 square feet, and the sealant needs to be applied every 6 months, or twice a year. How many gallons should he buy to protect the deck for the next 3 years? So let's figure out what the area is, and then how many gallons we need to cover the area, and then multiply that by how many times he needs to paint it over 3 years. The area of a kite was 1/2 times the diagonal 1 and diagonal 2. So our first diagonal is 40 feet, and then our second diagonal is 70 feet. 1/2 times 40 times 70 equals 1,400 square feet. So that is the total area needed to paint. So the area needed to paint, we could take that and divide by the 400 square feet per gallon that the sealant covers. If we're keeping track of our units, we're going to cancel out the feet squared because we have them on top of each other divided by. And then this gallon, it would be 1 gallon in the denominator, which means if we bring it to the numerator, it'll just be gallons. So 1,400 divided by 400 is 3.5 gallons of sealant needed each time he coats the deck. But remember, he had to coat it twice a year for 3 years. So how many times is that total? 6 coats at 3.5 gallons each time. So 6 times 3.5 gives us 21 gallons total for 3 years. So he needs to buy 21 gallons of sealant.